Hello everyone, my name is Christopher Jackson. Welcome to my Secure Network Architecture presentation for CYB 525. In this walkthrough, I'll explain how I designed a robust corporate network, the security tools I chose to protect it, share insights from my vulnerability scans using Greenbone, and discuss how this design defends against both current and future threats. By the end, you'll see how these layers work together to support business continuity. Let's begin. All right, so this slide shows my full network design. It starts with 2 routers and 2 firewalls, creating a strong perimeter to separate public internet traffic from the internal network. Inside the network, there's a core switch connecting key services like the DHCP server, proxy server, email server, and the vulnerability scanning tools. Traffic flows through an IDS and IPS for monitoring and blocking threats in real time. The DMZ safely hosts services that need to interact with external users. Finally, the network is divided into 5 segments. We have human resources, finance, IT, sales, and research and development, each with 25 client systems. This limits lateral movement if a device is compromised. To secure this network, I integrated 3 main tools. First is Greenbone Vulnerability Manager, or GVM, which automatically scans systems for known weaknesses, outdated software, and open ports. Second is OSSEC, a host-based intrusion detection system. It watches each device for unauthorized file changes, suspicious logins, or other unusual behavior. Third is Wazoo, which acts as a SIEM, or Security Information and Event Management Platform. Wazoo brings together logs from GVM and OSSEC and displays alerts and trends in an easy-to-use dashboard. Together, they form a layered defense that covers network scanning, endpoint monitoring, and centralized visibility. These tools don't work in isolation. They interact as an integrated security framework. For example, GVM might find that a Windows system has RDP enabled with weak passwords. While GVM reports that vulnerability, OSSEC actively watches that host for failed login attempts or unauthorized changes to system files. Wazoo then collects this data, correlates it with other logs, and raises alerts if suspicious behavior is detected. This approach means threats are not just identified, but tracked and verified in real time, giving security teams more time to respond. Running a full scan on multiple virtual machines can consume a lot of memory, so I divided my scan into 2 separate batches. The first batch included Windows 11, Windows Server 2019, Debian, Kali Linux, and pfSense. The second batch scanned Windows 10 and Ubuntu. I used my Kali Linux virtual machine to run GVM and ensured that each machine could communicate and respond to ping requests before starting the scans. This mirrors a real-time environment where scans must be planned around system resources and scheduling to avoid disruption. The results were very telling. Across my scans, GVM found 110 total vulnerabilities on 5 hosts. Notably, I discovered that some systems were running older protocols like SMBV1, which are known to be insecure. Open ports like SSH and RDP were also identified, which could allow attackers to gain unauthorized access if not properly secured. One important finding was that my pfSense firewall still used default credentials, a serious security risk. Based on these findings, my recommended steps would include disabling unused services, enforcing stronger passwords, patching all software, and tightening firewall rules to close any unnecessary ports. Today's networks are constantly evolving with technologies like cloud computing, IoT devices, 5G, and software-defined networking. While these innovations improve performance and flexibility, they also introduce new risks. For instance, IoT devices often have weak default security. Encrypted traffic can hide malicious behavior from basic firewalls. Zero-day exploits can bypass traditional signature-based defenses. That's why these tools like IDS, IPS, OSSEC agents, and Wazoo are so important, as they monitor for unusual activity even if a new attack method is used. Segmentation also helps by containing breaches within one department. All of these security layers and tools directly support business continuity. By using proactive scanning and real-time monitoring, the network is better prepared to detect, isolate, and recover from attacks without extended downtime. The air-gapped research and development system protects highly sensitive research even if the main network is compromised. This combination of vulnerability management, endpoint monitoring, and centralized analysis gives a company resilience against both common threats and sophisticated attacks, helping ultimately to maintain operations and protect data integrity. Here I've listed the references used for the project, and lastly, I'd like to thank you for your time, and until next time, goodbye.